Hello, Psychology of Learning students. So we're in week 3, chapter 3, and this is the second of 3 videos that go over this material. In the last video, I asked you to design an intervention that you think would work to get a friend or a significant other or a child of yours to perform a behavior less. So you were to think of a behavior that you wish someone would do less often or not do anymore at all, and come up with an intervention strategy that you thought would reduce that behavior. So keep that, we're not going to use it in this video, but we're going to use it in the third video. Keep that in mind. So the other thing that we went over last time is I just went over the basics of classical conditioning or Pavlovian conditioning, the way I would if I were teaching a general psychology class. Whether you took general psychology last semester or several years ago, we probably needed to clear out some cobwebs and sort of get you used to all the terms again. So that was the purpose of the last video. In this video, I'm going to talk about higher order conditioning and get much more in detail about classical conditioning. I'm going to talk about all the different variables that can affect the pairings and affect how strong classical conditioning is. So let's get started. And I'm going to get started by going to the PowerPoint slides. As I said before, these were created by Dr. Stephanie Stern, and I really like them, so I'm using them too, but she gets credit for all this hard work. So as I said in the last video, we did that practice activity and we went through the elements of classical conditioning. Today, we're going to go through higher order conditioning and other aspects of classical conditioning, like pseudo conditioning, extension. Okay, so higher order conditioning. When we look at higher order conditioning, we're basically asking the question, what if the neutral stimulus was paired with a conditioned stimulus? So if you remember, Pavlov's going to have the metronome get paired with food and the dog salivates. So the dog gets exposed to the metronome, it's making that sound. Metronome sound, food, the dog salivates. Metronome sound, food, the dog salivates. Metronome sound, food, the dog salivates. So now when the dog is just shown the metronome, the dog salivates. When he's salivating to the metronome, we call it a conditioned response. When he's salivating to the food, we call it the unconditioned response. But now the dog is salivating to the metronome. What we're asking here with higher order conditioning is, what would happen now if we paired a black square with the metronome? So we went black square, metronome, the dog salivates. Black square, metronome, the dog salivates. Black square, metronome, the dog salivates. After many pairings of that, if we showed the dog the black square, would he salivate? Even though the black square has never been paired with food, would that happen? And it turns out that in a study done by Frolov and many other people, sure enough, it does. The black square will lead the dog to salivate, even though the black square was never, ever, ever paired with the unconditioned stimulus of the food. It's pretty amazing. Now, if higher order conditioning didn't exist, you would not be having to take a required course as a psychology major that spent almost a third of the course talking about Pavlovian conditioning. It's only because of higher order conditioning that Pavlovian or classical conditioning is so powerful. Think about money. What is money? For most of us, money was a CS1. At some point in time, money became paired with something that led us to something, led us to a response that was good. So maybe money got paired with parental approval, which made you feel good. Maybe money got paired with food, which then would make you good, like ice cream, which made you salivate, but also made you have good positive feelings. So now things that get paired with money can actually be very motivating to you and give you positive feelings. So things that like, why would that happen? But it does through higher order conditioning. So with higher order conditioning, the CS that gets paired with the US, we're going to call a CS1. But then another CS that's paired with that initial CS will be called a CS2. And then you could get another CS that's paired with the black square, that would be a CS3. And then we can go out and out and out. How far can it go? Well, there's some researchers have gone as far as CS10. Now that only works with higher organisms like humans, and it won't work for all CSs as well. And it gets weaker each time. The further away you go, it's weaker. But still, we've seen this. So you can get responses that have just been paired with other things that have been paired with other things that have been paired with other things that have been paired with other things that were paired with the US that led to the UR at some point. So kind of amazing. Okay. So one area that your book talks about that I think is important has to do with word pairings to show how easily this can happen. What do you think of? How do you feel when you hear the words hot? How about pizza? How many of you, when you just hear this word pizza, are salivating right now? Or you're feeling really warm, like you have the sense of friends being around and eating a fun food? How about mountain? So like I hear the word mountain, I can picture me skiing with my family after Christmas all those years, and it brings back all these really warm, wonderful feelings. How about school? How about my name? What do you think of or hear when you hear these words? Probably these words, well, you're probably thinking positive things or negative things. These words either were CSs that were paired with USs, or it might have been that these words were paired with other words that were paired with USs. And so in one experiment, they paired positive or negative words with nonsense syllables like YOF or LAJ or QUG. And what they found was syllables that were associated with pleasant words became pleasant. And you guessed it, syllables associated with negative words became negative. So I can now pair, once you have a positive feeling toward pizza, I can then pair anything with the word pizza, and then through several pairings of that, whatever that is, I can probably now give you a positive feeling toward that. And that's pretty incredible. I mean, isn't this what advertisers are trying to do all the time? They're trying to get us to have their product get paired with something that gives us positive feelings, or their product is paired with something that makes us afraid. So then we'll do something using their product so to alleviate the fear. So all through higher order conditioning. Now remember that the further away you get from pairing with this US, the weaker the CR is likely to be. And I'm sure that higher order conditioning makes it very clear that how complicated this is, and how really measuring and even understanding the course of conditioning is much more difficult than it might first appear. So let's talk about how do we go about measuring it? How do we measure Pavlovian learning? So after we've paired the metronome with the food and the dog salivates, metronome, food, dog salivates, metronome, food, dog salivates, how are we going to measure, like, did learning take place? So we don't want to just continually look at the salivation to the food. We're going to have some test trials, right? We're going to do some test trials where we're going to just present the metronome and see whether or not the dog salivates. So we're going to look at what we call the latency. We're going to look at the time from when we begin starting the metronome to when the salivation begins on these test trials. And that we're looking at latency there. Another measure that we use for classical conditioning is we're going to look at the intensity of the CR. So with salivation, we're going to look at how much salivation, how many drops of salivation did the dog give to the metronome, okay? Now, one thing that can get in our way, there are always these confounding variables, these variables that end up affecting our dependent variable, in this case, our CR, and we think that it's due to the CS or our independent variable, but in fact it's not, it's due to something else. Oh, these confounding variables just drive us crazy. So one is pseudo-conditioning. And so pseudo-conditioning is with kind of intense responses, oftentimes just being exposed to that is going to make you more likely to give that response. And it has nothing to do with the CS at all. So what do we do to make sure that pseudo-conditioning is not what's happening, but actually classical conditioning is happening? We're going to use a control group. So we're going to randomly assign some dogs that are going to get the metronome, then the food, and they'll salivate. The metronome, then the food, and they'll salivate. The metronome, then the food, and they'll salivate. And eventually, after many, many pairings, we'll show them the metronome, and then we'll see the latency and the intensity of the salivation. To the control group dogs, so half the groups will be, half of the dogs will be randomly assigned to the classical conditioning condition, but the other half will be randomly assigned to the control condition. And the dogs in the control condition, for them, the metronome and the food are just going to be randomly shown to them. So they get the food, and then maybe a few minutes later, they get the metronome, measure salivation. They get the metronome, and then the food and salivation. Metronome way much longer, the food, do they salivate? The food, then the metronome, do they salivate? And then we're going to show them the metronome and measure if they salivate. And of course, we're going to look at the difference in salivating for the dogs in the control condition and the dogs in the classical conditioning condition. That's how we make sure that pseudo conditioning is not responsible for the dog's salivation for the CR, but it's really the metronome, the CS. Okay. All right, so we've kind of covered higher order conditioning. We've talked about how we actually measure the CR, how we know that the CS is causing the CR, how we experimentally look at this and measure it. Now we want to talk about the variables that affect Pavlovian conditioning, and there are so many of them. I'm only going to talk about the ones that your book talks about. The list just goes on and on and on and on. So one of the key ones, one of the most powerful ones, is how you pair the CS and the US, how you pair the metronome and the food. And there are 4 basic ways to pair it. And these are, they sort of give you a diagram on page 67 in your textbook that I think is useful looking at the diagram as we go through these. It's also one of the slides here, but if you're watching this right now, you might want to pause it, turn to page 67 of your book, and as I'm talking about it, you can be looking at figure 3.3. So the 4 basic ways of pairing the stimuli. So one of them we call trace conditioning. So with trace conditioning, the CS is going to begin, then the CS is going to end, and then after the CS ends, then the US will appear. So the metronome is going to start, the metronome will go, the metronome will end, and then the food appears. Okay? And you can see that that interval between when the CS ends and the US begins, that's going to be, that interval will play a role in things too. Okay? So trace conditioning, whenever we talk about trace conditioning, we're also going to talk about the time of that interval. Any questions? Well, I can't really ask questions in a video like this, but hopefully if you have any questions, you'll email me at maryd@cameron.edu. Another kind of conditioning is delay conditioning. So with delay conditioning, the CS begins, and while it's still going, it hasn't ended yet, the US will begin. Okay? And we have 2 kinds of delay conditioning, short delay conditioning and long delay conditioning. So like let's look at a short delay conditioning situation. The metronome begins, and the metronome maybe it's been going for a few seconds, and then the food appears. Okay? So that would be short delay. Maybe the metronome begins and it might go for minutes, maybe several minutes, and then the food appears. So notice how there isn't an interval between when the CS ends, the metronome ends, and the US begins, the food begins. They're going to overlap. Some of it's going to overlap. But clearly, the CS begins before the US appears. Okay? Both trace conditioning and delay conditioning work really well, especially if the interval between when the CS ends and the US appears is short with trace conditioning. Okay, so trace conditioning and delay conditioning lead they lead to quick and intense CRs to the CSs. They're very, very powerful. There are two more ways of pairing the CS and the US, but these last two don't work as well. Simultaneous conditioning, the CS and the US are going to start at the same time and end at the same time. So we're going to start the metronome and give the food at the very same time, and then we're going to stop the metronome and take the food away at the very same time. Okay? This is very much like if you give your dog food in a particular dish. You're presenting the food in the dish at the same time, and then you pull it away, take it back from them at the same time. Some dogs will still, it's not as effective, but some dogs will start to get really excited by just looking at the bowl. But most of the time, getting them presented and taken away at the same time is not going to be as effective as if you put the bowl down and then pour food in there. It's when they see you starting to get the food ready and they're looking at the bowl, then the bowl is presented before the food. And you can see how that short delay or long delay is going to lead to much better conditioning than the simultaneous conditioning. And the last one, backward conditioning, this isn't effective at all. There's a couple instances where people have found it to work, but it's not very effective. And this is when you actually present the food before the metronome. So they get the US first and then the CS. Backward conditioning is what it's called. Okay, and so I like this diagram. This is the diagram on page 67 where you can see the black box. This is supposed to be time. And then the black box is the CS and the gray box is the US. So you can see with trace, the CS begins and ends before the US starts. With delayed, they're going to overlap either a little bit or a lot. So if they overlap a lot, that's going to be long delay. If they overlap a little, that's going to be short delay. Simultaneous, they start and end at the same time. And then backward conditioning, you're actually going to get the US before you get the CS. And then they also have this flow chart, it's in your book on page 70, that will help you be able to identify whether it's trace, delayed, simultaneous, or backward. I like how your textbook made that diagram. I think it's very useful. Okay, so one variable that we've talked about now that's really important in affecting Pavlovian conditioning is how the CS and US are paired. We talked about the four different ways that it can be paired. Let's talk about some of the other things that will affect how well the learning takes place. And one has to do with the CS-US contingency. Contingency means how often does one appear without the other, okay? So if every time the metronome happens, the dog gets food, and every time the dog gets food, the metronome had happened, then there's going to be 100% contingency between the CS and the US. And what we find is the higher the contingency between the CS-US, the better learning takes place. The more quickly it takes place and the stronger it is. It's going to be more intense and more likely to happen. So now this would be a cognitive psychology kind of explanation for it, but it's like if contingency exists, if it's very high, then the CS becomes a good predictor of the US. If the CS is there at the metronome, then the food's a coming, right? Because you didn't get food without the metronome and you've never heard the metronome without food. So if those two always occur together, like slightly different in time, we want them to either do trace or short or long delay. But if anytime one is there, the other one will appear, and then neither one appears alone, then they're contingent upon one another. That's going to be really helpful for learning. Another thing that matters is that interstimulus interval. I was talking about this with the trace conditioning. The shorter the interval is between the CS and the US, when the CS ends and the US begins, if we're talking about trace conditioning, the more quickly learning will occur and more intense it is. So think about, I show you, or you show the dog, the dog listens to the metronome, but then, and the metronome ends, and then it's like a half hour later, the dog gets the food. Probably the dog is not going to start salivating to the metronome very easily. There's just too many things that happened in between there. So the shorter that interval, the more likely you are to get classical conditioning to happen and to happen more quickly. Okay, let's talk about another thing that's important, and these are the stimulus features. So these are the physical characteristics of the CS in the US, and they will affect conditioning. By and large, how it works is that the more strong or intense the CS is, the more likely learning will take place. And similarly, the stronger or more intense the US is, the more likely learning will take place. So, and if you have more than one stimulus, let's say you're going to show two stimuli at the same time, two CSs at the same time, the one that's stronger is going to overshadow the other one. And so it's very common for an animal to learn nothing about one stimulus. So if there's another stimulus there that's stronger, then it overshadows the first one. One example has to do with strong CRs. So I'm sorry, strong USs. So if you have a strong puff of air, there's a sound and a strong puff of air in your eye, and you blink, you're going to learn that quicker than if there's a sound and a weaker puff of air and you blink. So the stronger that US, in other words, like the stronger the puff of air in your eye, the quicker you're going to make that pairing. Similarly, the stronger or more intense the CS, the louder that sound is, the more quickly you're going to learn the CS-US combination. So that's what we mean by stimulus features. Intensity matters too. Strong stimuli will produce better results. Now, if it's too strong, it will overpower the whole thing and become ineffective. Oh, now this is fascinating to me. Some CS-US pairings are just easier to create than others. And usually this is true if there's an evolutionary predisposition or there's an evolutionary benefit for it. So it's much easier to pair, to get you to learn to avoid eating something if it leads to vomiting. Because so often when we eat something and we vomit afterwards, then we're going to learn not to eat that. That getting sick is due to eating something. Or if you sound a bell and then get you sick, it's harder to learn that. Pictures of snakes with fear are much easier to learn than pictures of cars with fear. And yet, you're much more likely to be killed in a car than bitten by a snake or die by a snake. But there's an evolutionary perspective here. So there's some innate instinctual pairings that are much easier to create than others. Another thing that's going to matter a whole bunch is the prior experience with the CS in the US. And to some extent, that is because it's going to affect contingency, right? So, so if you've been exposed to or if the dog has been exposed to lots of black squares, then it's going to take more pairings of that black square and the metronome before that dog is going to start salivating to the black square. The more things that dog had related to the food, the harder it's going to be to get another CS related to that food. Okay, so prior experience with the thing is going to make a difference. Okay, because of that, novel stimuli are going to be much easier to lead to classical conditioning. And we talk about blocking. This is if no new it's similar to shadowing, but if you have so much prior experience with something, then sometimes it's almost impossible for the organism to use that as a CS because it's just already connected with some other CRs. So getting it to be learned with another US and leading eventually to a CR just isn't possible. Okay. The intertrial interval, this is the gap between trials. We find that the longer the interval is, the more effective it is. The best intertrial interval may be 20 seconds or more for lots of different kinds of stimuli. And then other variables that play a role, this is how complicated it gets. Age. Older subjects seem to be less able, maybe because they have so much prior conditioning. It's harder to find a novel stimulus for someone who's older. but conditioning doesn't seem to be as effective in older subjects as younger. Temperament. More excitable animals tend to learn faster. If you're more susceptible to fear, you tend to learn faster. Stress oftentimes helps you learn classical conditioning. Not always, but in a lot of situations it does. So it's a very complicated process, but I hope you see some of the variables that do play a role. Now, once the CR is well established, it tends to last a long time, but we will talk next time about extinction, the times when it goes away, and then of course about some theories of conditioning that I think you'll enjoy. All right, look forward to our next chit chat.